Hello and welcome to 11.4 in the Big Ideas book. This is 3D, three-dimensional figures. So we're going to be talking about solids. So they're three-dimensional. They're just not flat pieces that we put on a piece of paper. They are three-dimensional figures. So any of these figures here, like if it's round like a sphere or the cylinder or your pyramids, cones, pyramids, prisms, they're all three-dimensional figures. So the polyhedron within the three-dimensional figures is a solid bound by polygons. So if you look at this figure here, these are all different polygons that each one borders or the edges share, and then they make a solid, a three-dimensional figure called a polyhedron. So in this polyhedron, we have faces. So you see that top colored piece is a face of that polyhedron. The edges are two vertices that are connected, and a vertex is a point. So a face is that flat surface. The edge is a segment that intersects with two faces. And your vertex is a point that intersects with three or more edges. So it may have more edges, like if you think of some of your pyramids that have maybe a base of a pentagon, all five of those sides come up to meet at one vertex. So we would have five edges coming up to meet at one point. So the different types of solids that we have are prisms. Prisms are going to have two congruent parallel polygonal bases. So in this prism, we could have the right side and left side, those two rectangles, be your bases because those two sides are parallel to each other and congruent. Or we could say that it is sitting on a base. So that larger rectangle on the bottom and the top, those could be considered the bases. And then the ones going around the side of that are your lateral faces. In a pyramid, the one in the middle has one polygonal shaped base, and all of your lateral faces are going to be triangles. In a cylinder, the two parallel bases are always going to be a circle, and in a cone, you have one circular base. These are all three-dimensional figures. So some of these are considered polyhedra, some are not. So to be a polyhedron or a polyhedra, that's when we're going to have all polygons. So if we look at this cylinder, it has that round, so it's not considered the polyhedra. Your prism, your cone, pyramid, sphere. Oh, cylinder is a polyhedra. Okay, so then we have our spheres. Three-dimensional shape. To name a solid, so now we're jumping into solid polyhedrons. So to name a solid, we're going to use the shape at the base is what we're going to use to primarily name these figures. So in this first figure here, I have to count the number of sides. We know it's going to be a pyramid because it only has this one base instead of two. So we know this is a pyramid. Okay, but now we have to count the number of 1, 2, 3, 4, 5, 6. So this would be a hexagonal pyramid. And we look at the next one. We have two parallel bases. So this is going to be called a prism. And we name it by its bottom. So this shape here. And they're all four square. So we can for sure say that this is a rectangular prism. All right, in the next one, we have a rectangular pyramid. And the next one, on the bottom, we're not 100% sure, but because it's a box, they usually do have those square sides. So we're going to say rectangular prism. If you said a quadrilateral prism, that would probably be okay too. When you look at this next figure right here that I'm putting in the box, you see how it's little pushed off to its side? It's not just square. We call this kind of figure oblique. So the volume of such a figure is going to be the same even if it's square, because if you take every horizontal cross section, it's going to be the same as the one that would be before it. It's just pushed over a little bit. So we have to name it by its two parallel sides. So if we look at any of the rectangular pieces, none of them have a side opposite from it that it is parallel to. But if you look at this triangle and this triangle, those two are parallel to each other. So we're going to call this a prism, and the shape of that base is a triangle. So this is a triangular prism. All right, what do we have? 1, 2, 3, 4, 5. So this is a pentagonal pyramid. This next one again is oblique. We don't necessarily put that in the name, but it is oblique, and we've got 1, 2, 3, 4, 5 sides. So this is going to be a pentagonal prism. This one, 1, 2, 3, 4, 5, 6. So a hexagonal prism, and this is going to be a triangular pyramid. All right, there are some special polyhedra. Some special polyhedra that we can talk about. What makes it special is that each one of these solids has congruent, regular faces. So some of the platonic solids that we have, the most basic one is a cube. So I'm not so great at drawing here, but if we start off, and that is a square, I'm telling you it's a square. And if I could do this so that I was perfect, which we know I'm not, this is going to be your smallest of the polyhedra. Four-sided, every single side is a square. So all 6 faces are a square. That's your cube. The tetrahedron is made up of 4 sides, and I'm not so hot at drawing these. So if you figure a 4-sided figure and a 4-sided figure, and they would be coming together at a base. So if this is kind of like your base where they come to, everything comes off as a square, and then they meet at a base of a square. So I do have one drawn in here to show, but the 5 platonic solids are tetrahedron, cubes, octahedron, dodecahedron, and the icosahedron. These polyhedron also have something that's called duality. So if you can see in here the cube, see the red one that we have drawn in here, so this figure right here, and looking through it, coming through, that is your cube. And the other one that it is meeting up with is your octahedron. Because if you look at the midpoints of all the sides, that's where the cube is going through the octahedron. So you see all the triangles coming together, and then this right here is a square. So coming through this part, and if we went back and around, that's where the square, so your triangles are coming down to meet at the square. These are called your platonic solids, and platonic solids, if you want to Google it to find out any information about that, and there are the 5 of them like I mentioned. We have the cube, the tetrahedron, octahedron, dodecahedron, and icosahedron. The cube and the octahedrons are duality partners of each other. The tetrahedron, its dual is the tetrahedron itself, and the dodecahedron and icosahedron are dualities of itself, of each other. All right, so the next thing we're going to talk about is vertices, edges, and bases. So if we are going to name this figure here, we're going to count the sides, 1, 2, 3, 4, 5. So we would say this is a pentagonal pyramid. Pentagonal pyramid. And the number of vertices that they are, so if we count A, B, C, D, E, and F, what do we have? 1, 2, 3, 4, 5, and one on top is 6. And then the number of edges that we have, A, B, 1, 2, 3, 4, 5. And then we also have the 5 going up. So we're going to have 10 edges. And all of those, the base is a pentagon, and we would name it by A, B, C, D, E. All right, and the second one, that is a cone with circle center at M. So this is a cone M. We only have one vertex, and it is point N. There are no edges, and the base is circle with center at C. Circle with center at C, and that's how we would write that, naming your edges, vertices, and bases. All right, one of the last things we need to talk about for today is there's a famous mathematician that studied vertices, edges, and faces in a polyhedron. And he discovered that every time, if you take the number of vertices minus the edges plus the faces, it always comes out to the constant number of 2. And this guy's name was Leonhard Euler. He was a Swiss mathematician. He was born in 1707 and he lived to 1783. So his name was Leonhard Euler. So Euler is the one, and you spell Euler with an E. E-U-L-E-R. E-U-L-E-R, and it's pronounced Euler. So let's just go through, and I just picked one figure. So we've got 1, 2, 3, 4, 5, 6 vertices. Then the number of edges this has. So the edges, we've got 5 going across the bottom and 5 coming up. So that gives us a total of 10. And the number of faces is we have 5 triangles going around, and then the one on the bottom, the pentagon. So we have 6 different faces, and this is going to equal or come out to 2, they say. All right, 6 minus 10 is a -4. -4 plus 6 is 2, and 2 equals 2. So every time we do this math, this comes out to be 2. Every time you take the vertices minus the edges plus the faces, it comes out to be that number of 2. And it was Leonhard Euler that made that discovery. All right, cross sections. Cross sections is the intersection of a 3-dimensional figure and taking a plane. So kind of think of taking a slice of something. So if we have this cone and we take right across the top, that is just a point. Now if I took a slice and went a slice right, whoops, I need my pen, took a slice right through the middle here. I don't have it drawn correct, but if we took a piece of paper, that piece of paper is only going to touch, not in the middle where that pen actually is, because that's air or space, but it would touch around this edge over there where that cone is and where it is over here. So the figure we would see of the cross section would actually be a circle. So if we look at this, we've got 1, 2, 3, 4, 5 sides. And if we took a piece of paper or a plane and cut that cross section and just took off the 2 and you looked at the top piece and the bottom piece, it's going to be basically the same shape as the bottom, just a smaller version of it. So that would also be a pentagon. All right, so in this one, what do we have? 1, 2, 3, 4, 5, 6. So if that piece of paper went through, this cross section would be a hexagon. Now looking at this cross section, so they're not going through parallel to the base. So this time when you look, it's going to follow the edge of that cone down. It's going to come across the bottom and go up this edge right here. So this cross section would be a triangle. All right, so more cross sections. This one's parallel to the base, so it would be a triangle. And the next one, it ends up being a rectangle, would be your cross section. All right, this is the last concept to talk about. And this is taking a solid revolution. We're taking a 3D figure will be formed by rotating a 2D shape. So do you see how we have this rectangle right here, and we're going to rotate it around this axis. So that axis isn't going to move, but we're going to rotate this around and around. And you can see in the second diagram here how that's rotating just a little bit. So when we rotate it all the way around, we get that full cylinder. All right, so now your homework is going to be a Schoology assignment. So it's not in your book like it normally is. So please check Schoology. Good luck.